So let's start talking about function, since as you can imagine, in a programming language which adopts the functional paradigm, function are the key concept, and we can define a function in Haskell by giving the function a name, and for simplicity, I will call this function f, and then providing a list of arguments, which when defining a function will be the parameter's name, which can be x, y, and z. And then all this is followed by an equal. And on the right side of the equal, we only have expression. In this case, I may want only to add these three arguments. So I will write x, y, and z. And that's it. This is a valid function in Haskell. And there is a lot to talk about this. We already see that the Haskell language server extension is doing his job by suggesting us to add a row that specifies the type of the function we just defined and is suggesting the type that GAC would interfere. In fact, this is the most generic type, and by clicking on the suggestion, it will add the row. But say I don't want this function to be that generic. In order to define my type that I want to specifically assign to the function, that remember is only the first name in this expression, and let me be just a bit more explicit about the name, and we define that the name func can hold values that have the type of an A to an A to an A that goes to an A, where the A is a number. Now, I don't want to be that generic, so I'm just going to replace this with 4 ints, in which the three first ints are intended to be the arguments of the function, and the last int is the result, but we'll get to this notation in a few moments. So, one important key concept when writing functions, but in general, any kind of variable in Haskell, is that you assign expressions to variables. In particular, since Haskell is heavily based on lambda calculus, you never have things such as return that you would expect in more imperative languages. Rather, when calling functions, you are constantly replacing the function call with the expression you assigned. And let me explain this by trying to run this function. And in order to test the function we just created, we can go on the GACI shell, and in the same directory in which the function file is, we can type .l, which stands for load, and the name of the file we want to load the definition of. So in this case, I want to load definitions.hs, and GAC will compile this file and then make a variable, whatever we define in this file, into the GACI shell. So now we do have a func variable, and we can ask for the type of func, and we see that is the type that we assigned to func indeed. Now, in order to call a function in other programming languages, you would have to write the name of the function and then provide the three arguments expected. But as we see, this is not valid syntax in Haskell. In fact, as I said before, function in Haskell are only expression that, when fulfilled, are substituted with the expression that we assign on the right. So in order to call the function, I would have to write the function name, in this case func, and then provide the argument as just by typing them. And this is a function call in Haskell. And what we have done here is going to check the definition of func and see that we said that when func is followed by three things, and these three things here are 1, 2, and 3 values. So when func is followed by these three things, substitute these three things in this expression as I'm telling you here. So what we do by calling a function is literally substituting the expression we assigned. And that's why we don't need return statement, because at the end of the day, one Haskell program is a big function that keeps substituting the parameters until he cannot substitute anything more. And that's one of the key concepts of lambda calculus. And perhaps we will have some specific video talking about lambda calculus, but that's really the most important thing that you have to keep in mind, that you are quite literally substituting the function with expression that have been assigned. So by writing func 1, 2, 3, we are kind of writing 1, 2, and 3. Now, an important detail here is how do we define functions, and in particular the type definition. And in order to understand that, you should have clear in mind that functions are first class values in Haskell, and that means that we can assign functions to variable, and we are doing something like that right here. But we can also, and most of the time we will, return functions from other function. And in fact, I can tell you we are doing that right now by this function here. In fact, in Haskell, you don't have anything such as function that takes three arguments, but you only have function that goes from a one argument to one single other argument. In fact, the function definition here is telling that func is something that goes from an integer to a function that operates with integers. In fact, I could very well store an intermediate call of the function with one single argument that I will call func2, and say that func2 will be substituted with the expression func and 2 as an argument, as first argument. And this is totally valid in Haskell. And we can also ask for the type of func2, and the type is exactly this one, since when we provide an integer to the func function, we get back another function that has this type signature, and we can already see that here. And this particular behavior is called partial function application, since we are not applying all the function but only partially by giving only some of the parameters required. And we can see that this func2 acts as the normal func that has 2 as first argument, and we can call, as an example, func2 with 3 and 4 as argument, and this will evaluate exactly to func with argument 2, 3, and 4. And that's because when calling func2, this func2 will be expanded to the expression we assigned to func2, and the expression of func2 is just calling func with 2. So this, as written here and as written here, get expanded to the same identical expression. And the same, of course, is valid also for the returned function. Also, the returned function has this definition in which, if provided an int, returns a new function, and only the last function, in this case, when provided an int, does not return a function, but only a fixed type. And that's why when we applied the last argument to this function we got by this expression, we are able to get something that is no longer a function, but a type itself. And that's why we get 9 as result. Now, an important thing to keep in mind is that functions, when called, are greedy. And by that I mean that if I try to pass to a function something like cube by 3, and then I want to pass some other arguments, we get some errors, since what is happening here is that since functions are greedy and function, remember, are first class values, so can be passed as argument to variable. What is happening here is that we are calling func with these arguments and then applying this result to the remaining argument. So what's happening here is that func, we are calling a function here, and this is greedy, and we'll try to keep everything follows until is fulfilled, so until it reaches, in this case, 3 arguments. And what's happening here is that it's taking, not quite correctly, but is taking the first argument as 2, and then since the multiplication is a valid function and function can be passed to variables, is trying to take in the multiplication as argument to the function, and the multiplication is not a valid integer, which we were expecting, and that's why we raise an error. In fact, the correct way to call this function would have been to use parentheses like this, since in this way, and we see that the function gets evaluated, in this way we are explicitly asking Haskell to first evaluate this, and once we get the result of this, then this of course evaluate to 6, and what we are asking here is to sum 6, 4, and 5, and of course this is 15. And since we asked explicitly to first evaluate this, then this is taken as a single argument to the function, and since this evaluates to an integer, then this is the effective call that we are doing, and this expands to the sum of the 3 arguments as we defined the function here. So this concept of function being greedy is really important, and we'll get used to this during the course. And one other important takeaway that you may want to keep in mind from this lesson is that function always get substituted. You got to think it this way with expression, and that's why we don't need a return, since Haskell programs are not much more than big expressions that get substituted in other expression, and so on, until it's no longer possible to substitute, as an example, this expression with anything else. Once we evaluate this, we get back the result, and that's why we don't need any return, since the result is the substituted expression itself. So we add our first look to functions. We will of course expand this concept that we saw in this video in the rest of the course. So if you like the video, remember to subscribe to the channel so that you can keep learning with me. If you want to support the creation of this content, you can always delegate your ADA to Harmonic pool. But at the end of the day, the most important thing that you can do is to stay decentralized. In any case, I want to thank you for your time, and I will see you in another video. Bye bye.